First one is 1/2, which is the square root. So it's the square root of 18. We want to break it down into the product of two numbers where one of them is a perfect square, the largest perfect square factor. So I have the square root of 9 times the square root of 2. Square root of 9 is 3. So we're simplifying this to 3 square root of 2. The next, it's a negative. So I'm going to flip this over to 12 over 1 to the 1/2 power. So this is the square root of 12. Then I'm going to break down into the square root of 4 times the square root of 3, which is 2 square root of 3. We add the exponents. A to the n times a to the m is a to the n plus m. A to the n divided by a to the m is a to the m minus n. And a to the n power and then raised again to the m power, we multiply the exponents to get a to the n times m power. Handle each of these. So now we have like bases, so we can add the exponents. But when we add the square root of 8 and the square root of 2, we can't add radicals unless they're the same. So what we need to do is we need to rewrite this as 3 and break the square root of 8 down in the square root of 4 times the square root of 2, which is 2 square root of 2, times 3 square root of 2. Now, since we have like radicals, 2 square root of 2 plus 1 square root of 2 is 3 square root of 2. So you can't add the square root of 8 and the square root of 2. The radicals are not the same. Now I could say, because I have 2 to the third, I could even make this a little bit simpler and say that this is 2 to the third, which is 27 to the square root of 2 power. Let's take the next one. We have like bases. We can add the exponents. So we have square root of 2 plus the square root of 2 is 2 square root of 2. And again, I could simplify this as 3 squared, or 9 to the square root of 2 power. The next one, I have a power raised to a power. So I can multiply the exponents together. And I get 8a to the square root of 16 as the exponent, and the square root of 16 is 4. So I get a to the 4th. The next one, I can divide and subtract the exponents as long as the bases are the same, but they're not. So I want to take 8 and write it as a base of 2 to the third power, and then raised to the pi power, divided by 2 to the second, which is 4, to the pi power. So I've got like bases now. And now I can subtract the exponent. I have 3 pi in the numerator, 2 pi in the denominator. I can subtract and get 2 to the pi power. So follow the basic rules for exponents. And don't deviate from those and you'll be okay. The next one, a power raised to a power, the square root of 2 times the square root of 3 is 3 to the square root of 6 as the exponent. And the next one, a, which is to the square root of 3 power, then raised to the square root of 12, multiply the exponents, and I have the square root of 36, which is equal to 6. So let's make a table of values. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. But also give yourself some negatives. 2 to the negative 1 is 1/2. So now when I sketch this, if I only took a look at that much of the graph, that is not really accurate. It doesn't show everything that's happening. But if I go to x being negative 1, I get 1/2. If I take where x is equal to negative 2, I'm getting 1/4. X is equal to negative 3, I'm getting 1/8. I'm getting closer and closer to the x-axis, but not touching it. So that's the exponential function. F of x equals 2 to the x power. Okay, let's graph f of x equals 1/3 to the x power. So we're taking 1/3 of the 0 power is 1. 1/3 to the first power is 1/3. 1/3 to the second power is 1/9. 1/3 to the negative 1, remember, flip it over and take it to the positive power, is 3. And 1/3 to the negative 2, flip it over and take it to the second power, is 9. So when we graph this, we have 0, 1. We have 1, 1/3. 2, 1/9, and we're getting closer and closer to the x-axis to the right of the y-axis. But on the other side of the y-axis, we have negative 1, 3, and we have negative 2, 9. And so it's going to go this way. So I want to take a table of values for this natural exponential function. And that would be e to the x. So if I want to take e to the 0 power, that's 1. E to the first power is 2.72. E to the second power, and you could get this from a calculator. So again, I'm not asking you to memorize them. I just want you to be familiar with what the graph looks like. And then to the negative 1 power would be equal to 0.37, and to the negative 2 power is 0.14. So again, we're getting 0, 1. And then we're getting 1, 2.72, and then we're getting a value up here for 2, 7.39. Negative 1, negative 2 are going to take us down this way. It's going to look similar to the graph where we had 2 to the x. It would also look like 3 to the x. And if you were to graph all three of them on the same set of axes, then e to the x would be between those two. So if we did one in blue and one in red and one in green, and the green one was e to the x, we'd see that between the other two, just to give you a feeling of where this would be and what it would look like.